Hey, folks, welcome to this week's episode of the Energy Sketch, a very special episode. I have my first guest ever on the Energy Sketch, Hayden Smith from FeX Energy.
Correction, FeX Energy. Links are in the description.
Thank you so much for joining us, Hayden.
It's an absolute pleasure, and what an honor to be the first guest on the Energy Sketch. I mean, I've been watching this since the first episode, and I'm just so inspired by what you're doing, Michael. And it's an absolute honor to be part of it with you.
Amazing. Thank you so much. Hashtag disclaimer, I work in energy and I have worked in the past with Hayden Smith, and I have worked and do work today with his collaborators who are at McGill University, and all opinions are my own. So, Hayden, I like to start at the big picture, and I know that you also appreciate Bill Gates and his book, Avoiding the Climate Disaster, and he talks about the big picture of our energy use and our carbon emissions, which are around these five things, right? Plugging in electricity, making stuff that's materials, cement, steel, plastics, growing things, getting around, transportation, and keeping warm and cool. So, where do you think this new technology fits? Which problems are you addressing with this new technology?
It's a great question, and it always comes down to first principles because if you want to reinvent the world, you need to think of it from a planetary perspective. And so the way that the world has become the global ecosystem that it today is really thanks to energy. And that energy, as you've talked about before on your show, came from the most part from eons dead life forms, basically compressing carbon and hydrogen into fuels that could then be extracted, refined, and used. And those fossil fuels have basically been the lifeblood of our progress as a society for the last 100+ years. Before that, of course, there was burning wood and things to keep warm, and we go back thousands of years, right? And energy was instrumental to life, and it still is. In fact, it's becoming even more important that we have stable and reliable energy because so many of the things we have come to be able to do are only possible because we have that stable and reliant form of energy. So the question really is, how do you transition 150 years or so of evolution away from fossil fuels that have been abundant, quote unquote, just pouring out of the ground, literally, into something that is equally abundant, but also sustainable in the way that it will not damage our planet as we're seeing is happening as a result of the combustion of fossil fuels. So FeX Energy, and the Fe is the elemental symbol for iron, which is basically the essence of our technology. And we'll talk about that in a bit, I'm sure. But basically what we're doing is we're finding an alternative, abundant source of energy that can replace fossil fuels, that can be equally dense or better, equally stable in that it doesn't just evaporate or go away, equally safe or more, right? So that it doesn't blow up or, destroy stuff around it and create risks that really we don't want more risks. And we've seen your show also on Lac Mégantic and the terrible disaster that took place there. I mean, that's even fossil fuels are not very safe. So we'd ideally like to be safer than fossil fuels. So the essential foundational principle of FeX Energy is how do you create an equally resilient, if not more, an equally safe, if not more, and an equally effective and efficient, if not more, energy system as today without fossil fuels and the emissions that come from them.
So many threads. We could talk about each of these for another year here. I love to start zoomed out, and I know that we have lots of philosophical conversations on this, and there's a mix of characteristics and values and societal values and integration of this new thing into an existing thing. There's many threads there, and it's nice to start big, but ultimately you're also running a startup business. And I guess one of the major challenges in running the startup business is finding your niche, and how are you going to grab hold in this wild ecosystem of things where people are searching for alternatives. So where have you chosen to plant your seeds, and where are you trying to grow specifically?
It's a great question. And if you look at Gates's book, which is exactly where we should be looking, how we make energy and electrify, plug in, so to speak, and how we make stuff, those account for the majority of emissions. How we move and how we transport and stuff, these are also important questions. But there are many applications of the technology that we're developing, and maybe what we should first do is quantify what are those special things about our technology, because to find the right application means that it's going to fit for that application. It has the right sort of technical attributes. B, it can be economically viable for that market and segment. And C, there's sort of like enough, it's a big enough problem to solve. It's worth investing the time and effort to solve, not just to generate revenue and to create a business out of, but also to create impact, which is the core foundational principle of FeX Energy. We want to make impact. We want to change the world for the better. And we believe energy and reliable, renewable energy is the essence of that. So the question is, what are the key attributes? What's special about this iron reactor? And the thing that needs to be specified, which you've talked about before on your show, because I know you're a huge fan of metals as an energy carrier, is that metals are abundant, right? There's metal all over the place. Most of the built world is made out of metal, some form of metal. Iron actually is, or steel is actually one of the biggest ones there. We transport iron and metal all over the world. So there's this infrastructure, there's already this backbone to use metal as an energy carrier. What's special about metal is that it's dense, so that it has, per liter, has more energy, actually, iron does, than fossil fuels. So that density that I talked about before, makes it a really nice solution for applications that are space constrained, that are brownfield. There's already maybe an existing plant or motor or something driving some sort of an application. So that's one part of it, the density. The stability of iron, right, of metals as an energy carrier. They don't just start losing energy with time. You actually have to do something, do some act on them in order for the energy to be released, because the energy is stored within bonds, right? Chemical bonds that then release energy in the form of heat as an exothermic reaction. And so that stability is a real advantage as well. We can store energy for a long, long time without big losses. What applications have a need for those long durations of energy storage? The safety, the fact that it doesn't just explode and spontaneously combust and isn't toxic, isn't corrosive. These are all really important things as well. So what industries or applications need that safety? And sort of resilience, efficiency, effectiveness. So these are other sort of attributes that our technology has, right? So look at the overall picture of global greenhouse gas emissions, the wheel, right, that you can find on Our World in Data or in Gates's book. He has an older version of it. And so like industrial processes, as an example, make up a huge percentage, 30-odd% of global GHG. And those processes also are heavily reliant on combusting fossil fuels to make high temperature heat, right? And it's interestingly, there's a bit of a circular thing here. Steel, for example, to make steel, you need very high temperature heat, like 1,000, 1,500 degrees, something like that. To make concrete, similarly, and Gates talks about these two as being big contributors to GHG, because for every ton of steel, every ton of cement, you're releasing at least a ton of CO2. And in other metals like aluminum, you and I worked together and came up with a number of something like 13 to 1. So, it's significant, the amount of emissions that come from this, some of which are from the combustion of fossil fuels. However, steel and cement, though they're the biggest, they're a little bit too high temperature for the technology we're developing. So our operating temperature is around 900 degrees C as an output. So what we're thinking is, like, what are the biggest greenhouse gas emitters that need up to 900 degrees C, and ideally as close as possible to that, because that limit is an advantage. It's hard to get to that temperature of heat. And so where is the biggest source of emissions that has as close as possible to 900 degrees C, that requires density, stability, safety, resilience, and so on. So we've come up with the petrochemical and oil and gas refining as two segments that are really attractive for that, because they need high temperature heat. Cracking of for petrochemicals is up to 900 degrees C, so it's exactly in that sweet spot. Refining is up to about 600 degrees C. Both of those, by the way, both of those processes today are contributing, I don't know, something like 8 or 10% of global greenhouse gases. So those two things are significant. We're talking about, if it's 50 gigatons per year of CO2, of GHG emissions, equivalent CO2, we're talking about 5 or something like that, gigatons. That's a lot, right? The other thing with respect to petrochemicals, people are like, what the heck are petrochemicals? Well, petrochemicals are basically the base chemicals that make pretty much everything in the built environment. From my coffee cup here to my drawing pad here to my desk to like pretty much everything is made out of plastic, right? Which requires petrochemicals like ethylene in order to be able to fabricate. And so the population of the world is growing. The per capita use of plastics and everything, the built environment is growing, right? As people become more affluent and more able to afford stuff and want stuff that, like this nice desk. There's someone in Africa that never had a desk that's now getting a desk. So these are increasingly becoming needed, these petrochemicals, and they don't release emissions when you use them, right? So people are all like, oh, we got to get off oil and gas. It's evil. It's bad. Well, the truth is we still need petrochemicals, which are coming from stuff that comes out of the ground, right? Like ethane and other anes. So the feedstocks for these petrochemicals in the future, a net zero future world, are still needed. We need to make them without emissions. That's the challenge. We need to make them without burning fossil fuels. And so we believe that this is an area that our technology is uniquely positioned to address because it can hit the temperature, because it has the density, the stability. It's even safer than today, right? They're not having to, pipe in natural gas, which is their current feed for energy that is volatile, it can escape, it's explosive, it can create fires and other environmental risks and human risks. So, we think we can have a solution that's even better than today and decarbonize entirely the petrochemical industry. And again, that's just one of oil and gas refining, other metals, metal refining, lithium manufacturing, nickel also require high temperatures. And there are no shortage of industrial processes that require high temperature heat that our solution can address.
A part of the thread for me there is, right, so the changeover of these industries. We need petrochemicals, we need those base chemicals to make stuff. You can be against like the waste of plastic and the excess of stuff and things go in landfills and all this like horrible stuff. I mean, there's so much plastic, and that stuff sometimes is overblown, and there's a spectrum there. But I mean, I think we can agree that we should be responsible and have circularity and all this stuff. And this is all possible, but we need stuff. I mean, particularly I've read in like health industry, the incredible advances of health that have been possible through plastics. I mean, we need plastics for so many things in our lives, and they are great materials. The carbon of that is sort of sequestered in the material. So if you're responsible with it and able to manufacture it and have it recycled and circular, all that is possible. So what you want to do is really decarbonize the upstream production of those things using this technology.
Yeah. Can I add one thought on
Yeah.
top of that? So the real problem with plastics, people always complain there's so much plastic in the ocean. It's where we put it afterwards, right? And that's just an economic problem. It's cheaper to dump it in the ocean than it is to actually recycle it or find some second life use for it. So this is another challenge that many other startups are trying to solve, the circular economy around plastics. But that does not negate the need for making plastics and for making them in a way that's responsible, that isn't destroying our planet at the same time. And by the way, to recycle plastics, you also need high temperature heat, which is primarily coming from fossil fuel combustion. So to make that circular economy, we still need to make that heat without carbon emissions. So that is a challenge, irrespective of even if we make a perfect circular economy of all plastics and we don't take any more ethane, let's call it, out of the ground. We still need heat to make that happen. So that heat needs to be decarbonized, and we need long duration energy storage solutions to make that happen, like ours.
Hey folks, Michael here. Thanks so much for tuning into this, just part one of my conversation with Hayden Smith from FeX Energy. Stay tuned for further episodes and we'll get into more details around the technology, and we'll be sketching those concepts on the whiteboard. Wishing you all a lovely 2024. All the best. See you soon. Toodaloo!